Okay, so we're back for lesson number 2. Maybe you'll get something out of this one as well, right? You never know. Okay, but at least you're here. And, I did that first lesson, and then some of my students said, hey, you didn't tell any jokes. And I guess in class, that's something that I like to do because, look, okay, honestly, this is math. This is not usually the class that students go, oh, dude, I can't wait to go to math class, man. Like, that never happens. And I always tell people, hey, I don't take it personally, but at the least, hopefully, you'll get entertained or have some fun in this class or maybe crack a smile versus just sitting there watching me do a whole bunch of math. So let's get into this. And as I was writing these down, I was checking email and somebody had said, hey, why don't you tell some jokes? And I thought, all right. So here's what happened. I told some jokes in my Algebra 1 class and my other YouTube video, and it didn't go so well, but I'm going to tell them in this lesson. And so hopefully, maybe I can do a little bit better. It was like halfway through the lesson and I thought, I could stop the lesson because I just destroyed this joke. But I figured, you know what, I'm just going to keep going. And if people laugh, then great. If not, then whatever, right? It'll be just like how it goes in class. So for this lesson here, I just want to recap. We're going to have 3 different types of solutions. I'm going to focus on the ones where there is a solution. So we have lines here where they're parallel, which means they have the same rate of change. Okay, they go up, over, and these are the same. And because those slopes are the same, these lines are never going to cross. And so we have no solution. Then we have a situation where we have a line like this, and they're going to have that one POI, or point of intersection. And this one has one solution, and then that's what we figure out. And that's what we're going to focus on in this lesson. And then we have the times when we have once you factor them or do a bunch of stuff, you realize, oh my gosh, it's the same line. And so because of that, we call these infinite solutions because it's the same equation. And so any numbers you put in the top equation or the first one, you're going to get as a result for the second one as well. All right, so let me erase these guys. All right, while I'm doing that, why don't I tell my first little joke here. We've been out of school for a while, and my wife and I are talking about all this stuff all the time now because, we're just kind of around. And she told me, she goes, I really hate revolving doors. And they actually kind of scare me because I'm afraid someday I'm going to get stuck in one. And I said, well, you know what? Don't worry. You'll come around eventually. Okay, maybe that one didn't do so well. It's just one of those things. Get it? Goes around. She'll come around eventually. Yeah, okay. I will say it is kind of weird to tell jokes in front of a camera and then nobody laughs and you're just kind of standing in a room by yourself. So that's just the way it's going to be. Although, you know what? That's just like how it is in class because I tell some of these jokes that I think are funny, man, and those things destroy. They're just so funny. And then other people are like, dude, I don't get it. Or they'll say, that's dumb, or that's not funny, or I don't get it. I get all kinds of stuff. But let's get back to solving these. All right, so we're being asked to solve these linear systems, right? They're called a system now because we have 2 things working together. They're going to crisscross, and because we're asked to solve them at the same time, we have different ways of doing that. And this lesson, because it's pre-algebra, is going to focus on a substitution method. And yes, in Algebra 1, you take it to the next level and you get all crazy with this stuff, but we're not there yet. So let's just focus on this. Okay, so I have 2 equations here, y equals x plus 2 and y equals 5. And what they want you to understand is that if y is equal to this, okay, let's say y is equal to, a, and y is equal to b, then can't we say that a is equal to b? Yeah, we can. And that's what they want you to do. They want you to turn these into something that's going to be equal to itself and then solve it from there. What does that mean? Well, I don't know. It's very technical, but whatever. We'll just talk through it and we'll do it and then you'll start to kind of see it. All right. So what I mean is we got to match these guys up. We know y equals x plus 2. So I'm going to rewrite x plus 2. We know that y equals 5. So essentially we're saying this guy is equal to that. Now this one is kind of small because I have an equation on one side and then the other one is technically it's a linear equation, right? Y equals 5, but we can just plug that in right there. And now we can solve this guy. Okay, so x plus 2 equals 5. Hopefully you're like, dude, Josh, what's the deal? This one is so easy. Everyone knows that the answer is 3, right? Because 3 plus 2 is 5. Yes, that's the answer, but they want you to go step by step and do this algebraically. And by that I mean, say we have x plus 2. So how do we get the 2 away from the x? Well, we have a plus 2, so we minus 2. We subtract. What we do to one side, you got to do to the other. We get a 0 and a 3, so x equals 3. Now again, you're probably saying, dude, I could look at this problem and just eyeball that. But they want you to start seeing that there's, there's these processes that we need to use in order to solve these problems. And they want you to start getting this stuff into your head because the rest of pre-algebra, you need to start thinking like this. And as you move into Algebra 1 and Algebra 2, you got to have that same mindset of I got to be able to move stuff from one side of the equation to the other in order to do what I want or make the equation do what I want. You need to be able to have those skills. And so that's how they're teaching it. So yes, it's great that you can look at this and say, oh, dude, the answer is 3 and be done. But are you getting the takeaway from the lesson? Not so much. And the minute I add decimals here, square roots, and all kinds of other big old numbers, like you could be here forever guessing some of these problems. Whereas if you follow the steps, you're going to get it every single time. So let me erase this first one because that one's pretty straightforward. Okay, so now I got y minus 3x equals negative 13 and 4x plus 5y equals 11. Okay, so the next method, if the problems aren't like this where it's super quick, where you can just plug this guy in right there because y equals 5, then plug it into the other problem. Now they want you to use a different method, usually called substitution. So first, what you want to do is figure out one of these equations has got to be made into a y equals something or x equals something kind of format. And so let me just do that with one of them, and then let's kind of talk through this as we go. Because it is kind of tricky, and the book has some weird ways they say it, but I want to just kind of make sure you visually see what's happening, and then kind of interpret it in your own way. I got to make this y equals something, or I got to make it x equals something. Now, all of these x's have numbers next to them, so that's complicated. This guy has a number next to it, that's complicated. But if I add 3x to both sides, this stuff all disappears, and I end up with y equals, and then I have 3x minus 13. Right? I just reordered it so that it just looks prettier. It's in that y equals mx plus b format, but either way would be okay. And so what I did was I said y equals all of this. Now, in the previous problem, you'll notice I took that 5 and I plugged it in where the y was in the other equation. Now I'm going to do the same thing, but instead of having just a number value right there, I have this extra part, okay? I got more than one thing. And that's okay. It just means you're probably going to need a calculator. You might just need to just be very neat with your work. And I always stress that with students. Like, take your time. Spread your work out. Make sure you know what's going on. So I'm telling you that, or we've now figured out that y equals 3x minus 13. Okay. So let me rewrite the first part of the problem here. I got 4x plus 5, but it's 5 times y. Remember, anytime you have a number next to a letter, it's multiply. And so what I'm saying is 5 times whatever y is equal to. And what I can now do is substitute all of this in for that value of y, because I just figured out that y equals this stuff. But it's also 5 times whatever is in there. So let me write it out that way right here, okay? I have 5 times, so in order for me to multiply, I'm gonna put in those parentheses, and now I'm gonna fill in all this stuff, 3x minus 13, and then the rest of the equation just says what? Equals 11. I got a lot of stuff going on, and this is where I say you gotta spread out your work. You gotta take your time with this so that you really can see, like, step by step, what are you doing? Before you start combining stuff and doing other things, I would work with this right here and distribute the 5 so that I have all my numbers all together. So I have a 4x, that just stays as it is, plus 5 times 3x is 15x. Positive 5 times negative 13 is negative, I don't know what. So let me just get my calculator. And again, if you're in a class where you can use your calculators, then that's awesome. I highly recommend it. I think that it's something that by 7th, 8th grade, it should just be something you can use. But you should know your math facts, because when it comes to square rooting and factoring and doing some of this stuff, the faster you know your math facts up to your 13s, it does save you a lot of time. Just my little public service announcement. 5 times 13, I don't know, that's a big number. 5 times negative 13, I guess if you want to do it that way, 65. Okay. So I get minus 65 equals 11. I'm hoping you're seeing that I'm going step by step. I'm showing everything that I'm doing. I'm explaining all my work. And now I'm going to combine like terms. 4x's plus 15x's is 19x's. Minus 65 equals 11. And just like the last video, if I'm going too fast, because I know I have a lot of math to do, pause the video. If you think you got it, try the next problem and see if you can get it. And then watch me do it and be like, yes, I can do it. Or I made a mistake, but now I know why. You can always pause this and go back. Okay, so from here, now I'm just solving for x. So let's see here. I got a minus 65, so I'm going to plus 65, which gets me 19. Now I'm getting way down here. 19x equals 65 plus 11, which is what, 76. I'm hoping that that divides equally, but let's just find out. 76 divided by 19 is 4. Who would have thunk it? Not me. So, and the way I got that is I divide both sides by 19, and so I end up with 76 divided by 19 gets me 4. So I'm just going to write it kind of like over here. X equals 4. I did all this crazy math and I get one answer. X is equal to 4. Now to solve for y, you now need to plug that number in to one of the other two equations to solve. And I always say, go with what's easiest. Okay, I know I've kind of drawn on everything here, so by now, hopefully you've either stopped the video and you've written all this down, or you followed along, or it just makes sense, because I do want to be able to kind of get rid of some of this and then be able to continue on with this problem. So let me just kind of, you know what, I'll just start over. How about that? The problems are right here, and most books will say, take this and go right into one of those. But even if you move stuff around, you're going to get the same answer. And that second equation that I made was already in y equals 3x minus 13 format. So if I plug this number in for x, then I'm going to get my value for y. So rather than using the actual problems they gave me, I'm just going to go with what's quicker, because this one already says y equals something, so why wouldn't I just plug it in? 3 times 4 is 12. 12 minus 13 is... 12 minus 13. -1. No, I'm just kidding. I just like to do that sometimes just to kind of stall. I don't know why, it's a habit. But what I have done is I have figured out where these two lines would cross. So it's over 4 down 1. I don't know where these lines are. I'll just say, like, let's say they're like there and there, whatever. I know, but I do know that at 4, -1, they're going to meet. And that's what we're looking for when we solve these algebraically. All right? So let's move on to that third problem. And like I said before, send me a message if this isn't making sense. Let me know if you need one extra problem. I'm trying to do ones from our book just so that it's pretty straightforward and you can look at those problems. In our math book, there is those little personal math tutor buttons at the bottom, you know, the online book, so you can watch the online video as well. Maybe that'll help. But do something for yourself, okay? This last one here, let me write this guy down. Y equals x plus 5, 2y minus 2x equals 10. Let me just kind of make a line right through those. Sorry, those are kind of close together. And now I need to do the same thing. I need to solve this by substituting one problem into the other. Now on this one, I have y equals a bunch of stuff. So then that's probably what I should insert into the other equation, x plus 5. So let me just start to rewrite this. It's 2 times y, right? It's got a 2 there. So I do have a 2. Then I have my x plus 5. And let me remove some of these because I'm going to go a little faster here. Then I have what? Minus 2x equals 10. And at this point, you're probably doing what? I don't know. You're probably hoping I tell another joke. So why don't I tell you something that might be a little more with today, you know, we're taking all these days off, everything, you know. So I don't know if you heard in the news today, but Finland announced that they were closing their borders. And so what does that mean for us? Well, unfortunately, it means that nobody will be crossing the finish line. I thought that one was actually pretty good. But once again, you know, if you think you got better, then send me a joke, man, because I do my best and I try to, you know, keep students engaged and excited about this stuff because, like I said, I mean, I was never good at this one. I was in middle school and it took me a long time to be able to get to where I could actually appreciate what we're doing here. Let's see here. So I got 2x, 10, 2x, 10. This guy's already looking like a special situation. So let me just double check over here. And so what do we end up with? Well, if I combine my like terms, 2x minus 2x is 0. And so what do I end up with? I end up with a 10 equaling a 10. Okay? And so anytime you get a situation like that where the x values or the y values disappear and you end up with like 4 equals 4, 6 equals 6, it's called infinite solutions because you'll start to notice, oh yeah, it's the same problem. This is a factor of 2, and if these are all multiplied by 2. So if I divide this by 2, this by 2, this by 2, I end up with the same equation. And so in this situation, yeah, my x's disappeared, but the main thing is that 10 equals 10, which once you get down to numbers like that, this is one of those infinite solutions. Okay? They don't come up a lot. The main goal is to have you work on these kinds of problems because they really, you guys, it's so important for you to get good at substituting stuff into these equations and working with them. It's really important, especially if you're going on to Algebra 1 after this, which most of you are, okay? You're going to get some where it's infinite solutions just to kind of trick you. You're going to get some of those ones where it's no solution because it has the same slope. The only way these can also get a little bit more complicated is if they add in like fractions or decimals. I don't want to focus on that right now because I just want to make sure that with the basic formulas here, these equations, these linear systems, can you move stuff around? Can you insert certain values and get an answer? And at this point, that's good enough, okay? Anything additional, I would say we can cover in class where, we have more time, but it is tricky because I want to make sure we're going through these at a reasonable pace, but I don't want to go too fast to where you're just completely lost. And I don't want to have here's the main idea, and then here's a bunch of exceptions to it. So oh yeah, when you see this, don't do this. Or when this happens, make sure you do this. I don't want to confuse people. I want to make sure we're going right to the heart of the work. Here's how it gets done, and then we'll move on. And at some point, if we go back to school, if something happens where we're able to work again together, that's when I'll talk about the exceptions. But if you know the main stuff, then we should be good to go. All right? So, hope you liked my jokes. Hope this stuff made sense. I hope you'll be back for the next episode. Send me any questions you have. I truly am here to support you guys. This is a crazy time. This is unprecedented for us to just not be in school for months probably. But we're going to do this. We're going to do our best. And so at the least, if this is reasonably making sense, you are doing amazing, okay? I know it's hard to just learn from somebody on a video. And so I definitely want to recognize that and say thank you for following along. It's very complicated for some people to do this. And so if some of it's making sense, that's okay. Even if just it's a little bit where you're I think I kind of see how this is going. If you got it and you're trying these problems and you're working on more of these and you're getting them, then that's fantastic, okay? That's so great. But even if it's just barely making sense, if you're starting to kind of see what I'm doing, that's okay. You will have time to go back on this at a certain point, okay? So, great job going through these problems. Get started on assignments. Send me questions if you have them. If you have an awesome joke, feel free to send that and I'll try to get you on the video. Otherwise, stay tuned for the next episode.